Now we will try to see the 16 losses and some of the KPIs, that is key performance indicators of the maintenance. The 16 losses are basically segregated into three types: availability, performance and resource. I'll just read it for you. What are covered under performance? Breakdown loss, setup loss, tool change loss, minor stoppages, shutdown, defect and rework, startup, speed loss. Under performance, motion loss, management loss, line organization loss, distribution loss and adjustment loss. While under resource, there are three types of losses: yield loss, energy loss, consumable loss. We'll try to see in details what does each of these loss means. Availability loss, the first loss is basically a breakdown loss. As the name suggests, basically the machine is not operational due to the failure. Now this failure might be because of the any of the reasons, say spare part is not functioning, machine is malfunctioning, or some bearing is not working. That basically the thing because of which the machine is moved into the breakdown or is basically called as a breakdown loss. Setup loss, again, why this many times it is question is been asked. The setup is very necessary things to do because we want to have a production from one X part to Y part. Then how one can call it as a loss? See, the thing is basically during setup there is no good product that is coming out of the machine. That's why this is basically as good as loss for the equipment. That's why it is basically called as a setup loss. Tool change, again, whenever a machine is not producing anything because of the changes in the tool, it is called as a tool change loss. Minor stoppages, generally machine gets stopped due to some of the minor issues, say less than 5 minutes, which generally do not get documented into the production report. We call it as a minor stoppages. I'll give an example of, say there is one sensor whose position is get disturbed, and because of which there is some kind of a malfunctioning that is getting observed. So what operator will do, he will quickly stop the machine for some time, he will adjust particular sensor and again will start the machine. So these are categorized under minor stoppages. Shutdown loss, again machine is not working because of, say shutdown because of, say, power loss or scheduled maintenance activity, anything. So that will be called as an availability loss. Defect and rework, machine producing a defective part, ultimately my capacity is getting wasted, and that's why defect and rework loss is basically an availability loss. Speed loss, the machine is not working with respect to its intended speed but with the less speed, then it is again basically a speed loss. The performance loss is basically there are various type like motion, management, line balancing, distribution and measurement and adjustment loss. Likewise, I told availability loss is more or less related to the equipment getting stopped or stopped functioning, whereas the performance loss is basically not because of the machine is getting stopped because of its malfunction or because of some breakdown or something. Machine is available, however it is not able to perform its work because of certain reason, and those reasons are basically categorized under performance loss. The first one is a management loss. Now what is a management loss? A waiting for resources such as material or tools. Motion loss, like in the last section 2s session I have told you that if an operator is moving from one place to another place just to take a tool or just to take some kind of an inspection tool, he comes back again by moving 10 to 12 steps and then checks again, goes back and keeps them. So these are the excessive motion which is causing my machine to be under stop condition, though it is available for performance or it is available to perform. Line balancing loss, this is typically comes whenever there is a bottleneck, whenever there is basically the line manufacturing is there, and since the material is not available from the previous station, my equipment is waiting. That is why it is called as a line balancing loss. Distribution loss, man hours getting spent or getting invested because of the some other work. For example, चलो आज ट्रक लोड करना है तो let us stop, operator is being asked to load the truck rather than working on the machine. So this loss is basically called as a distribution loss. The last one is a measurement and adjustment loss. Likewise, if my parameter is if my product is not coming up with the specific limit or it is going towards the resolution that has been provided, then operator is supposed to do some kind of a setting and adjustment, and the time getting lost into that is basically called as a performance loss. Loss is basically a resource loss. Now what is a resource loss? Now resource loss is a little bit different as compared to the availability and performance loss. Let us try to see what is yield loss. Now whenever we convert any of the input into the output via process that has been happening on the machine, if the expected results are not achieved, that is a ratio of output to input is not as per the standard, and if it is less than the standard, then whatever additional material is been wasted is basically called as an yield loss. Like you are into a press shop and then you are having some kind of an yield that is defined for particular sheet. If you are not achieving that and we are finding more scrap than what is expected, then it is called as a yield loss. Energy loss: whenever you are converting a material from input to output, there is certain energy that it is expected to convert that input to output within that specific limit of energy. However, whenever that energy goes beyond that particular standard, it is called as a energy loss. Similar concept is applicable to consumable, because there are some standard consumables that are supposed to get consumed during the conversion, but if it goes beyond that particular standard, then it is called as a consumable loss. Now the important part comes about how to capture those losses. So I am here just explaining one of the loss data format which you should use on your shop floor. Now what it does contain? It contains date, shift, part number, operation on which it is getting carried out, target production, from which time to which time that production was happening, what is the actual production quantity, loss code, and remark. Now what is this loss code? Loss code is basically reason because of which my actual quantity is probably less than target production. See, there is, if at all there is any difference between what is the actual production, say actual production is 90 whereas target was 100, then what is the reason for those 10 quantities not getting produced has to be mentioned over here. Now what are the various loss codes? You will understand in the next slide. Format wherein which you should be capturing all the data related to breakdown. See what is happening on the shop floor. If you are only taking the data with respect to calling it as a breakdown, then that won't be helpful for us to do any kind of an analysis afterwards. One need to understand for what reason it was under the breakdown, and what kind of a repair you have done, what kind of a countermeasure you are taking, so that it will give a input to the preventive maintenance. So this is one of the format wherein which you can mention the breakdown abnormality. Similarly, you can have a data collection norm at the company level also, where you should mention who should collect the data, by what frequency you should collect the data, where that has to be recorded, and all other details. Of the availability loss code that I was talking about in previous slides. For example, breakdown loss, no operator, no material, die setup, crane not available, pallet not available, scrap removal, quality problem. So if you try to understand, these reasons may or may not be similar to each and every shop floor. So these are what we observed over the period of time, and that can be generalized loss code that we have identified. A company can add as well as delete some of the loss code if it is not applicable to them. Now we'll try to understand some of the KPIs, that is key performance indicators of the maintenance. The one of the most important KPI of the maintenance is basically, I can say, OEE, that is overall equipment effectiveness. However, we have dedicated session for the OEE, and then we will try to cover that under that session. Another KPI is basically PM schedule versus actual. See what happens whenever we do any kind of an preventive maintenance schedule. We need to actually see its performance also in terms of its timeline. For example, it has been scheduled on 1st of the month. However, it is not done on the 1st of the month, and it was done on the 3rd of the month. So we really need to understand the compliance of the schedule. So we can say this KPI basically as a PM schedule versus actual. The another important KPI is the MTTR, which basically stands for mean time to repair. It is basically an average time it takes to repair a system. If you ask me the formula for that, then it is basically total time spent for repairing divided by number of repairs. Let us take an example to understand the MTTR. See, there are 3 breakdown reasons on a particular day, which is basically maybe a driver problem for 15 minutes, chain issue for 25 minutes and bearing replacement for 50 minutes. Then what is my MTTR as per the formula? It basically says total time spent on repairing. So what is my total time spent on the repairing? 15 plus 25 per 50 divided by number of repairs. That is how many number of repairs? 3. So you will get, it is basically 90 divided by 3, that means 30 minutes. So if I ask you what should be the ideal value of the MTTR, see, it is basically a time to repair. That means my machine is waiting for my repair. So it should be as minimum as possible, correct? So ideally MTTR value should be as low as possible. Let's understand the another KPI of the maintenance, that is MTPF, which basically says mean time between failures. So MTBF is basically used to identify the average time lapse between the failure that need to be repaired. So what is the MTBF in terms of formula? It's total uptime divided by number of failures. Let us take an example to understand the MTBF. For example, a mechanical mixer designed to operate for 10 hours per day. Suppose the mixer breaks down twice within 5 days. Its uptime was say 40 hours. Then the MTBF, as per the formula, what it says? Total uptime divided by number of failure. The uptime mentioned here is basically 40 hours. What do you mean by uptime? Basically time for which the equipment was running, the mixer was running. So 40 hours divided by 2, that is equal to 20 hours. So what MTBF is basically showing us? It is showing us the time lapse between the failure. So if I ask you what should be the ideal value of MTBF, the answer should be, it should be as large as possible, unlike MTTR, which was as low as possible. Now MTBF should be as high as possible because it basically shows me the distance between two failure. How to improve MTTR and MTBF? Right, so whenever we talk about the MTBF, it is basically time lapse between the two failure. So if you see, MTBF has to be backed up with a good proactive action, which talks about good preventive maintenance, good corrective maintenance. The thing is basically anything that is avoiding my machine to go into the breakdown has to be done in order to improve my MTBF. Whereas what is MTTR? Machine is already into breakdown and we need to make it live as early as possible. So if you see, the skills plays a really a good part over here. So I need to have a very good skill set when it comes to the maintenance. I need to have good spare part management if at all I need to make my equipment live as early as possible. I need to have good maintenance technology. Now let us take an example of spare part, how it affects the MTTR. Suppose you are into your machine is into the breakdown and you do not have any other critical part in your spare. So what will you do? You will go outside or you will keep a purchase order and then the lead time will start. Until that time my machine will be under repair and my MTTR is going to increase over there. So I hope you understand what do you mean by MTBF and how to improve MTBF as well as